so this is essentially a case study on Grid Smarter Cities ADAPT project, which started in January of 2019. It ran for roughly 6 or 7 months, and at the end, we basically only paid about £100 for this development. I did check the exchange rate this morning. It worked out to be about £104, so maybe not quite under £100, but we probably could have optimized costs maybe a little bit. Right, so talk a little bit about the project, what it did, the technology that we used, kind of how we built it, the architecture and the build process, and also what the final kind of bill was. So no surprises on the bill, but I think the biggest surprise is maybe going to be the comparison to a traditional kind of server-based approach. So no surprises, we've gone for a serverless development here. So ADAPT is the Assistance for Disabled Air Passenger Travel project. What it did was it helped disabled passengers when they were at an airport. It got them the assistance that they required where they were at the time that they needed it. It also helped to manage the airport's load around how passengers requested assistance and also how they, could provide that assistance. We spent roughly 5 minutes kind of building it, and another month and a half of testing it in an alpha or beta release. So I've called that a production application because we're using it with real users. It's not staged. Everything about it was real. So we've all kind of seen these stories in newspapers or on TV news where people who are disabled don't get treated the same as another passenger. It's horrible. It's not nice for them. As you can see here on these headlines, it's a terrible experience for those people. So the first thing we did was identify the user personas. We came up with the 3 kind of actors. We've got a passenger who will request the assistance. We've got an assistant who provides that assistance to the passenger, and their movements are coordinated by the passenger kind of coordinator who gets the initial assistance request and can then kind of distribute to whoever they can provide that assistance, whether it's a mobility issue or hearing or anything else. They get the right person to the right place at the right time. So the current passenger journey and why it's probably so horrible for them, they have to call the airport beforehand to notify them they're going to be arriving. Once they get there, there's no kind of prior notification or anything. They have to kind of check in at a desk. If they are in a wheelchair, they will be taken to a holding area and just kind of like left. Then they go through security. They go into another holding area, and you're basically stuck in this holding area. You can't really go anywhere. Even if you want to just use the toilet, and you're perfectly capable of doing that yourself, you just can't. You need to have somebody kind of with you there. So what this ADAPT project did was kind of give the control back to the passenger. So as they were approaching the airport, there was a geofence that was triggered that would send a notification to the airport to tell them, this passenger is on their way and they're going to need a certain type of assistance. Once the passenger has done that, they're on that list. The coordinators are aware of them, but they don't need to do anything at that point because no assistance is required. When they do need assistance, they can essentially just tap the app tap the button on their app. That will notify the coordinator. They can then start organizing the assistance that's required. They pass that request off to the assistant. The assistant can then go and see where that passenger is on an integrated internal map. So in this case, we had another company partnering with us that had internally mapped all of Heathrow Terminal 3. So we could see on the map where the assistant was and where the passenger was, and they'd be able to see each other so they could, find each other essentially. And then there was also two-way messaging between the passenger and the assistant, so even better coordination happening with that. In terms of the technology we used to build this application, heavily in AWS serverless, did a combination of REST endpoints and WebSockets. Obviously, DynamoDB is a NoSQL database, uses key value stores. We use some push notifications through just Android, Firebase, normal notifications, as well as Vapid for the browser notifications. As I mentioned before, the internal mapping provided by the third-party company called Living Map. And obviously, as I just said, we took a serverless approach to how we built it. So Sam went into a lot of detail about what is serverless. I think it was Matthew Clark from the BBC also did a lot of serverless talks this morning. So most people are probably fairly well aware of what serverless is now. Back in January of 2019, this was, I think, still pretty new, and still is pretty new now, but it's starting to get a lot more mainstream. But the biggest thing for us is that it allowed us to focus on, building the business value rather than worrying about how to, how can two servers talk to each other. We didn't really need to do that. It takes care of all that kind of stuff for us. As it mentioned on there as well, auto scaling, high availability, and you pay for usage as well. So the pay for usage thing comes in at the end as well. We'll go over the bill, break it down a bit, and we'll see exactly how much it cost us. So for the architecture, we did take a domain approach, microservice approach, and we built 3 different services, one to handle the APIs, another service to handle all of our outgoing notifications, and another service to handle the profiles of the user, so photographs, as well as a bit of a profile information on maybe what disability they have, so that coordinator knows a lot more about that person. We also followed AWS best practice and did multiple accounts for each service. So we had essentially a development staging account and a production account for each of those services. So that's actually 6 AWS accounts altogether. We did a CI/CD pipeline for every service, every account. And we also, for the users, 3 different Android apps. Sorry, that should actually be, that's a mistake, 2 Android apps and 1 React web application. So this is what it looked like in the end. Those dotted lines are the services. It's a bit low level this, but you can see the adapt service is the big one on the left, notifications, a bit smaller one on the top right, and that profile service is bottom right. So you can see there's lots of different lambdas with code in there, lots of different databases as well, or tables, I should say. We use different tables for Dynamo, as well as that red thing as well was Cognito, which was our authentication provider as well, another service provided by AWS. This is what it looked like from an account point of view. So each of those a different account. You could see the code in GitHub in the middle, going out to each service as and when it needed to be built. So when a pull request was created in GitHub, that went to a build project in whichever staging account it was in, built a full clone of that service in that pull request sort of environment, did all the necessary tests, and then came to the end of the build where somebody would peer review it and then get merged into master, which would then push it out straight to production. So we could potentially raise a pull request and get something out to production within about 15 minutes, which is obviously quite handy if you've got some hot fixes or things that are quite urgent and needing to go in. So the bill, as you can see in the very bottom right-hand side, $137.48 for basically all of that. So we broke it down kind of by month and by account. You can see that the staging accounts cost more than the actual production versions running the service. Now that's mainly down to the fact that the build jobs are done in the, all the testing is done in the staging accounts. So that's kind of the higher cost there. But yeah, so it was really interesting where obviously as we moved along, the costs increased because we're using more and more services and we're kind of adding bits and pieces together. So you can see, we didn't really look at profile stuff until kind of the third month. Even the normal API stuff we didn't really look at until kind of the second month of development. So if we look at it on a kind of a percentage graph, I guess, bar graph, you can see that the main bulk of the spend was in that that adapt staging account, the API account, where all the APIs were, and that's where we did the bulk of the testing as well. So if we look at the services that were used, this is consolidated across account as well. So the highest spend was just actually in building and running the CI/CD pipelines. So $57. Tax is for some reason listed as a service in AWS, but it's funny. Tax is our third highest spend on services. You can see in terms of user authentication, Cognito didn't cost us anything. Lambdas, so those are the things that are running our code. Over 6 months of development, including testing, building, testing or using in production, testing in a staging environment, 1 penny across 6 months. What else? Dynamo, our database services cost us $1.45. So I found this to be quite incredible, actually. That ECR spend as well, that $19 spend, we pretty much eliminated that now, actually. So we don't actually store images. We used to have an image for our builds. We don't actually do that anymore. We use the AWS standard images. So, dropping that, it's almost 15% of our build just storing images. So yeah, so we could have done some optimization there as well. Again, looking at service, spend by service, you can see that in July, we dropped actually the code build spend because we were mainly focused on production and users kind of using it. So you can see that there's a higher CloudWatch, which is kind of monitoring and logging, much higher in July than it was in June. So you can see that kind of switch where we went from kind of building and testing to kind of live usage. Now, if we compare this with traditional architecture, where let's say we've got a server to run our, let's say a Jenkins instance, we'll have a server to run our APIs on, and we'll use a normal SQL database, probably something from RDS. You can see the costs there quickly rack up to be over $1,000 for the 6 months of development time and testing. That's just for the servers running as well. You still have to work out your data ingress, outgress, load balancing, networking. And then if there was going to be 10,000 people using this, you do have to start factoring in availability, scaling, all of that stuff, where if you take the serverless approach, in this case, not only is it much cheaper for us, but we get all of that availability and scaling and networking thrown in for free. We didn't have to do anything for that. As we went through the project, we were learning some new things. So back January 2019, we didn't know a huge amount of AWS, serverless, and the services within AWS. So we learned some stuff as we went. So API Gateway, Lambda, they had some limits on sizes of data they could handle. So things like a profile photo, typical smartphone cameras, probably getting close to 20 megapixels now. Couldn't put that through API Gateway or Lambda. So we now go directly to S3. Another thing we found was that Dynamo streams, if something fails, it does this constant retry on the failure. It doesn't actually process anything new coming in until that failure is taken care of. So we have to make sure that we handle all those possible errors. This was our first thing with WebSockets as well. And we found that they're a bit tricky to test. So one of our really good developers, Rob, he basically wrote this WebSocket testing library, which I'll mention a little bit later on as well, to help kind of do that asynchronous testing. We also found that you could hook up API Gateway directly to other services. So you could go from API Gateway straight to Dynamo. This requires using something called a VTL template, which are horrible to write, almost impossible to test, and definitely not recommended. So we found, you kind of, for a bit of maintainability going forward, I would definitely recommend having that Lambda kind of in between those two things. The other thing about Dynamo, it's a great database service, but it's a different pattern than your normal SQL database. And we found that the queries we were writing, the access patterns were changing quite regularly, which meant the indexes needed updating quite regularly. And that's quite a difficult thing to do. So I would recommend you probably want to use an SQL database and maybe do a migration later on when you know that your access patterns are a bit more stable. As we mentioned, we did write a bit about open source library, so that PyWSI test is a Python-based WebSocket testing framework. We also wrote a thing called the Python serverless template, which is a starter project with some lambdas and some build pipelines kind of already set to go. We also wrote this other thing called the AWS Lambda decorators, which is for Python-based lambdas, where you can extract your parameters from your events, validate them, add your CORS responses, do logging, handle exceptions. It's quite a nice one, actually. And then there's also the AWS DynamoDB parser, because when you query Dynamo, you don't get back a nice object. You get back a bunch of stuff and metadata kind of around it as well. So this is a library that kind of filters it down to the things that you need, not the rest of the stuff. Right, so that's me. Any questions so far? We've got, looks like 2 minutes left. This is that really awkward thing where I kind of just stare at the screen and wait. Right, Emer, does the cost savings scale up for a larger project? Well, yes, I would say. Matthew this morning said, if you're doing a serverless thing for, let's say, video encoding or transcoding, you probably end up paying more for a serverless project. I think so. It definitely depends on kind of what you're doing. If it's a thing that will kind of go up and down in usage, I think serverless is going to be a better use case for that. If it's something that will kind of go up, stay steady for a bit, and then maybe drop off, tomorrow, you probably, from a cost point of view, you might want to look at a server-based approach. But you also want to factor in things like total cost of ownership, which includes, like people's time for doing things like networking and, maintaining those servers. Cheers, Emer.